Hi everybody, welcome back. This is AP Chemistry, Chapter 4, Lesson 5, I think it is. And today we're going to talk about how to write net ionic equations given mixing two salt solutions. So as you can see in your notes, there's 3 different types of equations that you can write. The general equation that we've always been writing is called the molecular equation. It gives the overall stoichiometry, so the overall coefficients and how they mix together. It shows reactants and products, but not necessarily in their actual form. For example, we have listed KNO3 aqueous here, but in reality, remember, if you could look with your Miss Frizzle glasses, that would not be stuck together, right? It would exist broken down into the ions that compose it. So complete molecular form is the form that we've always been writing. The other type of equation is a complete ionic form, where anything that is soluble is broken apart, and anything that isn't is kept together. So it represents ions of your reactants and products that are dissociated. So in going from the molecular to the complete ionic, what you will do is you will break apart any strong acids, strong bases, and soluble ionic compounds. So you'll have to be using your solubility rules. Everybody else you'll keep together. Okay, so everybody else you'll keep together. So notice that this is aqueous. It's a group 1. It has potassium in it, which is a group 1. All compounds that have group 1 elements are soluble. So you would break this down into potassium ions and chromate ions. Since there's 2 potassium ions, you get a coefficient of 2 here. Notice, since you're breaking these down into ions, they must have the charges. So since this is a soluble ionic compound, we break it down into the ions that compose it. Barium nitrate is also soluble because all nitrates are soluble. So we'll break that down into barium and 2 nitrate ions. Barium chromate is insoluble according to the solubility rules. Potassium nitrate is soluble, so you break that down. So in going from the molecular equation to the complete ionic equation, you break apart any strong acids, strong bases, and soluble ionic compounds. Everybody else you keep together, okay? Everybody else. If it's a weak acid, keep it together. If it's a weak base, keep it together. If it's covalent, keep it together. If it's insoluble, keep it together. Only break apart strong acids, strong bases, soluble ionic compounds. To remind you, your strong acids are your strong 6, HCl, HBr, HI, HNO3, H2SO4, and HClO4. Those are your strong acids. Any other acid, any other thing with H first, you keep together. Only break these guys apart, okay? Your strong bases are all of group 1 with OH. So I'll list a few. I'm not going to list them all. LiOH, NaOH, KOH, yada, 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 all the way down the group. And it's the bottom 4 in group 2. I'll just list those ones. It's the calcium hydroxide, barium hydroxide, strontium hydroxide, and you'll never really see radium hydroxide because it's radioactive. So it's all of group 1 OH in this. Any other base you keep together. Oops. So that's your complete ionic equation. It has all the ions in it. Your net ionic equation removes any spectator ions. Spectator ions are ions that are unchanged in the course of a reaction. They look the same before the arrow as they do after the arrow. They do not participate in the reaction at all. They only watch. They are spectators. Just like a spectator at a soccer game or a spectator at a football game. They do not participate, they only watch. So if we look at the complete ionic equation, you'll notice some things that are on the same on the left as they are on the right. Perhaps you notice potassium ions. You have 2K plus ions going in and 2 K plus ions coming out. They are the same. They are spectator ions. Another spectator ion is the nitrate ion. It's the same before, it's the same after. So when you go from complete ionic to net ionic, what you really do is just remove them. They're not participating in the reaction. They're just still floating around like they were. So you remove the spectator ions. So you get rid of that, and then what you can see left is the net ionic equation, which represents the only thing that is actually changing in the course of a reaction. So chromate ions are combining with barium ions to make barium chromate, which is your solid precipitate. Okay? So let's try a couple of these together, and then I'll have you try a couple on your own, and you could bring those in tomorrow, and we'll start there. So aqueous potassium chloride is added to silver nitrate. You want to start with the molecular. The same thing we've always done. So potassium is K, chloride is Cl. Look up their charges, +1, -1. So we'll have KCl as our molecular formula for potassium chloride. It's aqueous, so I'll add the AQ symbol after that. We're adding that to silver, nitrate. Silver's +1, nitrate's -1. Those equal 0, so there's no need to crisscross. And that is labeled as aqueous also. Okay, so we're combining what we did in last night's practice, where whenever you mix two salt solutions, they always wife swap or undergo double replacement, a metathesis reaction. So the K and the Ag will swap partners. So the K will now get together with the NO3. And since this is +1 and that is -1, that's the formula. And the Ag will get together with the Cl. Okay? So we write the correct formulas for our reactants. We wife swap and perform double replacement, and then we write the correct formula for our products. Then we ensure that the equation is balanced. 1K, 1K, 1Cl, 1Cl, NO3, NO3. It's balanced. If it was not, you would go ahead and balance it. That is your complete molecular equation. Now we do the complete ionic equation. I'm just going to do it down here. We'll do this guy in a minute. Complete ionic equation, CIE. In going from the molecular to the complete ionic equation, now we think about solubility. And we break apart anyone that's a strong acid, one of our strong 6, strong base, or soluble ionic compound. So this is not an acid, it doesn't have H first, it's not a base, it's not with OH. So we need to identify using our solubility rules if this needs to stay together or break apart, okay? Potassium's in group 1, all group 1 compounds are soluble, so we should break that down into the 2 ions that compose it, which are K plus and Cl minus. According to the solubility rules, all nitrates are soluble, so break this down into the ions that compose it. Again, all nitrates are soluble, so break that one apart. And according to the solubility rules, chlorides are mostly soluble, except when combined with silver. That's one of the exceptions. So keep that together. That's your complete ionic equation. Now we go from the complete ionic equation to the net ionic equation, where we take out the spectators. Who looks the same before and after the equation? And what you probably notice is it's K plus and NO3 minus. So really who's participating in this reaction and who's changing is that the chloride ions and silver ions are combining to make a solid. Those ions are being removed out of solution and they're making a precipitate. And silver chloride is a white precipitate. That would be your net ionic equation. Okay? So let's do the next one. We'll do one more example and then you can do a couple on your own. In this one, I would recommend that you pause it and do not reveal the answer until you've had a chance to work through it. Okay? So aqueous potassium hydroxide is mixed with aqueous iron 3 nitrate. First thing we're going to start with is the molecular equation. Please pause the video now and try to write your molecular equation, and then you can compare it to mine. All right, hopefully you've unpaused the video now and you see that they do wife swap. The Fe is now with the OH. Fe is +3, so it's FeOH3. The K is with the NO3. And I need to balance it so it looks like that, right? 3 Ks here, 3 Ks here, 3 NO3s, 3 NO3s, 3 OH groups, 3 OH groups. So we're balanced. Okay, we're going to now write the complete ionic equation. Remember where we break apart any strong acids, strong bases, or soluble ionic compounds. So pause the video now and see if you can come up with the same complete ionic equation as I do. Yeah. You can come be on the video, so, unless you're in a witness protection program or something. All right, I guess I should be pausing it so you don't have to watch me write, but that's what you should come up with for the complete ionic. Anything with group 1 is soluble. This is a strong base, it's soluble. All nitrates are soluble, break them down. This is a weak base. It's not a group 1 with OH, right? Or the bottom 4 group 2. And again, this is a nitrate, so you break it down. So you should be keeping together your iron hydroxide. Make sure the parentheses are around your OH. That's a common mistake. All right, now we'll write the net ionic equation where we remove the spectator ion. So again, pause the video and try to come up with the net ionic equation. Okay, did you get the same net ionic equation as me? You should have 3 OH minuses react or bond with 3 iron ions to remove each other from solution to produce solid iron hydroxide. It is not necessary for you to write phases, but I find phases are helpful. Remember, if anything is an ion, it must be in the aqueous phase. Okay? I'm going to have you do one more here. Let me pause this for just a moment so I can bring it on the. Okay, so I'd like you to do number 2 on this bottom list. It's sodium sulfite combines with acetic acid. Sodium sulfite combines with acetic acid. And what I would like from you is the molecular equation, the complete ionic equation, and the net ionic equation. Again, here it is. Sodium sulfite combines with acetic acid. I'll pause the video, you work for a minute, and when you come on, we'll have the answers revealed. All right, hopefully you have the right answer. So sodium sulfite, Na+1, sulfite, SO3 - 2. Those don't equal 0, I crisscross to get Na2SO3. Acetic acid, it doesn't have hydro in front, which means it's not a binary acid. It has a polyatomic in it. The polyatomic it comes from is acetate. So acetate is C2H3O2, and since it's an acid, H is first. So you have HC2H3O2 as your formula for acetic acid. They wife swap, they undergo double replacement, so now the Na is with the C2H3O2, and there's its formula. The H is with the SO3. Those don't equal 0, so you crisscross. You balance your equation, and that's what you should come up with. Anything with group 1 is soluble, I broke it down. This is a weak acid, I kept it together. Anything with group 1 is soluble, I broke it down. This is a weak acid, I kept it together. And then I simply just remove the spectator ions to get my net ionic equation, as you can see there on your screen. Okay? So we'll do some more practice with this in class tomorrow. There is only one video tonight, so just this lesson 5. And we'll do a lot of practice with writing net ionic equations tomorrow. Have a great night, everybody. We'll see you in the morning.